Okay, thank you so much for joining. I think we're going to go ahead and get started. So thank you all for joining day 2 of this virtual workshop. Um, this session is our final 2 keynote speakers. Our first speaker is Tim Ahern, who was the director of Iris Data Services for 31 years until 2019 when he retired. He is now EarthScope Emeritus. When not traveling with his wife Nancy, he remains active in the International Federation of Digital Seismograph Networks, FDSN, working on 2 projects related to data standards in seismology, as well as operating a 7-station network of seismometers in schools in Washington State. We are thrilled to have Tim here with us to give this keynote talk. And so without further ado, Tim, if you're ready.
Yep, I'm ready. I'm sharing my screen. That look okay?
I can't see it yet. I'm not sure. There we go. Yes, perfect. The floor is yours.
Okay. Good morning. I know it's quite early for most people, but it's beginning of the day here in Seattle. So I appreciate being asked to give a short presentation on a project I've been working on since I retired from Iris, related to legacy data, and specifically to try and standardize the metadata captured when working with legacy data, trying to bring it into a more usable format. My co-authors are Lorraine Wang, Joseph Batlo, and Javier Quinteros. Lorraine is the co-PI on a large project that works on different aspects of legacy data. And Joseph Batlo is the head of the European Seismological Commission working on legacy data. Javier Quinteros is the chair of the FDSN Working Group 2 on data exchange that deals with formats. And this is what I'm proposing, a new format for legacy data. So I want to just give a quick overview of the project, the motivation for the FOLDS project, talking a little bit about fair data. I'm reusing a talk, and I think this audience is more familiar with the concept than the previous audience. The scope of the FOLDS effort, what it's going to do and what it's not going to do. The process of identifying the FOLDS metadata, which was quite involved on an international scale, and then the concept of how to make the data actually fair, being accessible by anyone on the internet. So it's a concept similar to what the Federation does for time series data now. This is related to making easy exchange and sharing of image data. So the effort started with a workshop organized by Lorraine Wang, mostly, coming from a 2018 National Academy of Sciences Committee on Solid Earth Geophysics report that showed the importance of capturing legacy data. Specifically, I think this was related to seismic data, but what's evolved is actually more generic in that it can deal with any sorts of time series, paper, analog recordings of time series data of any type. We saw some talks yesterday, and it would be amenable to those types of data as well. Both NSF and the USGS expressed interest in the Academy report, and Lorraine wrote a workshop proposal that resulted in a workshop in Albuquerque, New Mexico in September of 2019. We had 29 participants from universities, US national labs, government agencies. We had 4 international participants in that workshop, and we also had a good representation of early career seismologists. The themes from the Albuquerque workshop are shown on this slide. We had the science drivers, the motivation for doing this, related to data preservation, what are trying to identify best practices, generation of metadata needed for legacy data, which is really the part of the project that I've been most actively involved in. Had other things that I'm really not going to address. Software specifications and systems for scanning and vectorizing the data is out of scope for the FOLDS project. And also in future directions, repositories and holdings catalogs. This falls directly out of the FOLDS effort once implemented. Knowing what data is available and what's not also is addressed by FOLDS. Fairness of the data and using standard approaches are very much the focus of FOLDS. And also the development of a pilot project, which is also in scope for FOLDS. There were several other things that are out of scope of FOLDS. So I'm really focused on those, on the few items there that are in bold. First of all, I'm not going to belabor this much since I do think this community is familiar with FAIR data and their concepts. It means findable, accessible, interoperable, and reusable. And the main driver of this, you can find out more information if you go to gofair.org, FAIR principles. And the main driver of FAIR data is to make the data optimal for reuse of the data by other scientists and even scientists outside the domain of, in my case, seismology. There are three major activities related to legacy data that are involved in this. One is the conversion of the physical media to an image file or a data file of some type. The analog records can be paper records, microfiche, microfilm, film chips, analog tapes, smoke glass, etc. Wide variety as long as they can be imaged and result in an image file on disk. There's the process of vectorization. Once you have the image, you have to turn it into a time series data. And again, these two aspects are not in scope for what FOLDS are, but they are in scope for a closely related project to the FOLDS project are addressing those activities. I'm really focused on the generation of standard metadata for images and supporting FAIR characteristics using an application that is yet to be developed, but has been specified. So in scope for FOLDS is the ability to create, curate, manage, and distribute standardized metadata for images of physical media. It's also a system to develop service-based approaches for a federation of data centers, very similar to what the FDSN currently has implemented for digital time series data, very analogous to that approach. There are synergies between FOLDS and the Born Physical Studied Digitally project that Lorraine plays a big part in, also Suzanne Vanderlee at Northwestern University. And they're really involved in converting the physical media to image files using standard techniques and specifications, as well as the extraction of the time series data or vectorization once the image has been imaged. So we approached this problem by identification of metadata fields that have been captured in a large variety of projects that were involved in capturing analog data and imaging them in the past. I've got a long list of data centers there. These are the ones that actually responded to the request for information about what metadata they captured. And I won't go into the detail, but you can see it's involved not just in US agencies, but internationally involvement. I also asked the IRIS DNC staff at the time, this was done when I was still the director, to provide additional input, and they were quite helpful in doing that. We identified a superset of elements of 7 types. The time period of the data, stations and channel metadata, metadata about the sensors, the recording systems, the image files, and a few other miscellaneous elements. There were a total of 39 elements identified at that point. At the Albuquerque workshop, we asked the attendees whether or not they thought those metadata elements should be required, recommended, or made optional, or in some cases excluded from the list of standard metadata. At that point, we then reached a very broad as possible list of seismologists around the world using a variety of list servers. We know we sent the request for information to about 6,500, may not be unique. They may be on multiple lists, but about 6,500 seismologists. We attempted to have them fill out a survey to get their feeling about whether or not the 48 metadata elements at that point should be required, meaning that it must be included to be included inside the fold system. And they would become queryable as parameters for search, all of the required ones. The recommended ones will be included in the database of folds if they are provided. And if the fields are populated, they could also be used for query and search. Optional fields would be stored in the database, but would not be used as search criteria. And of course, there were some fields that came out that were not included in the final set of folds metadata. So the survey results were compiled for the FDSN, the International Federation of Digital Seismograph Networks. And we did include additional fields submitted by the respondents to the previous survey I just mentioned. Working Group 2 in the FDSN voted to proceed with the effort, and they did establish a technical review committee consisting of Bob Engdahl, who many of you know, USGS retired, Ina Sokolova from the Kazakh National Data Center, and Joseph Batlow, as I mentioned previously, chair of the European the ESC Commission on Legacy Data. The review committee prepared a report, and as part of their report, they determined fairness of all the required, all of the metadata elements they determined to be required moving forward. At this point, the metadata increased to 56 elements. It entered an FDSN community consensus phase, and it passed unanimously at the Berlin IUGG just summer of 2023. So don't worry, I'm not going to go through all 56 metadata elements, but I wanted to show you how I'm going to present this. I used the subset of data related to time of the data in this example. It has the start time, the end time, and the timing correction, for instance, a brief description of the element, the type of data that we're expecting to have come back. Many of these follow the seed convention that many of you are familiar with. And if it was deemed to be required, as you see in the column over here, if you can see my cursor, there were altogether 19 required elements, 25 recommended elements, and 12 optional elements. If it was determined that it was a required element, they actually evaluated whether it contributed to the various components or aspects of fairness. Now, I'm not going to go through the details here, but at least you'll have a copy of this talk and you can see the metadata that was defined from this rather extensive process that took actually about a couple of years to reach the state that it's in at this point. So 3 time elements, 12 station channel elements, 8 metadata elements related to sensors, 4 recording system elements, 6 Tessio, which is the Italian application that actually did the vectorization of the data. And they're related very much to helical scan recorder data. So they were never were required, but they were just recommended if those metadata elements were known. And then about the actual scanned image, there are 20 image file elements. And again, I'm not going to belabor each one. You can review them later. And then 3 additional elements that didn't really fall into the previous categories. And again, a total of 56 FDSN identified metadata elements were identified. We're attempting at the present time to coordinate with the similar activity of the Comprehensive Testband Treaty that started with this set of metadata elements and have modified it in a few ways. And we're working to try to bring those 2 efforts together presently. I want to talk about how to access these data. Federation of Data Centers is a concept well known within the FDSN. It's where you can have multiple data centers that put up identical service interfaces and as such can become nodes in a federated system. You don't have to have all the data at a single data center for users to easily access the data. An example of this right now, if you go to the FDSN web pages, you can find a map of almost 34,000 permanent stations from 23 distributed data centers around the world, and you access these seamlessly. So here's a map just showing the permanent stations that are available from one of the 23 data centers in the federated system. So folds, what will it be? It'll be an application to generate the metadata at legacy data centers. It'll manage the metadata in a database management system. It'll allow curation to update the metadata as needed. And it'll expose the metadata and the digital artifacts, which are the image files or thumbnails of the image files, by querying a metadata database using web services. It'll distribute the metadata in an XML format via web services, and it will distribute image files resulting from a query of the information catalog that's contained in the database in standard formats via web services again. Very similar to how time series are distributed by FDSN data centers now. Legacy data centers could continue to manage and distribute the metadata and artifacts from their local data center as part of a federated system. You don't move the image to a central location necessarily. They could be managed in this distributed system, or if you want to, you could have a redundant or a centralized node that contained all of the images, all of the digital images that are participating in the fold system. By using intelligent workflows, we're trying to minimize the amount of work to create the metadata. If you think about it, many of those metadata fields that I showed earlier don't change between one, let me say, helical scan recording to the next. They're often sorted in time order, and most fields don't change. So those fields would be automatically filled in, but be easily editable as needed. We do limits checking, obviously, to make sure that there's some sensibility in the metadata that's being entered as it's entered. Folds can support either station sorted images or time event sorted images, those for instance, a nuclear test or an earthquake, specific earthquake. It will enforce entry of required metadata fields, and it'll make it straightforward to include recommended and optional metadata fields. Again, we realize this is a huge amount of work for a data center to create this data, and the goal is to make it as easy as possible. We are proposing, and they were approved, an FDSN style of web services for access. There'll be a folds availability, which points to a list based on your query, the existence of a digital artifact matching your query. For instance, for a specific time period in a specific part of the world, it would tell you what images exist and where they are in the federated system. It's very similar to the FDSN availability used for time series. Optional information can be returned if the user requests it, but optional fields would not be queryable, as I mentioned before. Fold station is the equivalent of FDSN station for those of you familiar with the services. It really is a way of returning the metadata related to the metadata elements that I showed previously in the folds database. And then in time series data, there's an FDSN data select web service. We're producing one called folds image select, where it returns, instead of a time series, it returns either a thumbnail of the image for a quick look or the actual digital image files of the scanned analog artifacts. It won't create a new event service for earthquake information. It will make use of the existing FDSN event web services at existing federated data centers. Here's a quick graphic kind of showing how things work. The upper left-hand corner, folds will have input and configuration interfaces. It'll have a folds metadata database management system. Down at the bottom of the light-colored blue box, it has the folds image select, folds station, and folds availability, which are web services. And the storage can be either local storage at one of the federated centers or a storage in a cloud-based system, yet to be determined. It's flexible. It doesn't care where the actual scanned images reside. There is a service registry where each of the folds data centers would register themselves and make their services known to the outside community or for applications. Users would interact to the fold system using applications similar to like SizeComp or OBSPy, which are known now. And again, the FDSN event service lies outside of folds, but could be used by any of those applications. I have talked to many data centers around the world. The ones with the asterisks in this slide show ones that have agreed to and show an interest to participate in a beta test of the system. Almaty in Kazakhstan, Kyrgyzstan, Russia, Tajikistan, UC Davis has a collection. I've got Almaty duplicated there, sorry. Boston College, Harvard have all agreed. I also have reached out in a Romanian and a Turkish data center that I met the participants for in the CTBTO meeting last summer, would like to be involved in this as well. And I'm sure there are all others, but at least I have a good subset of international data centers interested in participating. Next steps for the folds are complete the coordination between the FDSN and CTBT, identify the funding sources, which I've been working on and have identified some possibilities, and finalize the software specification for the folds application, select a contracting team to do the development for a beta version, and then seek the actual legacy data centers and start working with them to be beta testers of the system. And then, of course, training and promotion of the system through a variety of meetings will be part of it. Thank you very much.
Thank you. We can now take some questions from all of our attendees. If you want to use either the chat or the Q&A function, I'll give you a couple minutes to type those out if you have them. We have a question from Emily Brodsky, who says, what funding has been identified and how much do you need?
No specific, I haven't finished the proposal. I haven't submitted the proposal. I'm still working on the proposal. I believe that the folds project through this is about a $300,000 effort. Best estimate. Don't hold me to it.
A next question from Christos Evangelidis. So a centralized FDSN event is needed that looks across all available images?
Now, the event service has hypocenter information from places like the ISC and the USGS, or any of there's several European data centers that also put up event services. So, so specifically, if you wanted to do a search based on specific events, you would get the information about the events through one of those existing services that the FDSN data centers already run. We don't need to reproduce that capability.
Thank you.
If I answered your question, I hope I did. It's not really looking across images, it's looking across hypocenter catalogs.
All right, but just I was thinking in case you have, let's say, 10 images, then from 10 different earthquakes, then you should have a catalog with only these events, right? Instead of searching across many, many events. That's what I'm saying. You know, a catalog that contains only the legacy data you have, the scanned earthquakes you have.
That's they'd be associated with the images are associated by the time to the time of the events. But there is, we did not include in the metadata, there's an indicator that there may be an event present on the image, but we don't try to identify the actual hypocenter. That has to be done with an association later.
We have another question from Helen. How could individuals not currently involved in this project submit data?
The goal is to have an initial set of beta testers, but this is an application. Anybody that would, any data center that would want to participate in the future would not necessarily be part of the beta system, but could easily be part of the the final application when it's available. If anybody's interested in being a beta tester, I'm sure we could accommodate that too. I just don't want the group to grow too large. There's just one of me.
Thank you. And we have another question from Carlos Cardona. FDSN has data, or does FDSN have any data from any volcano observatories?
Sure, and I won't be comprehensive on this. I'm looking close to home. I live in Washington State. The data from the Cascade Volcano Observatory, for instance, and all of the University of Washington network that monitors the Cascade volcanoes along with CVO. Data are available in the FDSN. And I'm sure that's true. And I'd be very surprised if Greece and Italy and the various things do have a lot of data that are from volcanoes.
Thank you. We have, I think, another question from Jerry Carter. Are there standards for the resolution of the images?
That's a work in progress. I think it's out of scope for folds to say what you should scan images at. It's part of the Born Physical Study Digitally effort. And Lorraine, who may be online, might want to speak to this too. We have ideas of what makes sense, whether it's 600 dpi or 1200 dpi and things like that. But that's actually out of scope for folds, but it's certainly part of the bigger effort that's taking place right now. Folds just captures the resolution that was used in a database.
Thank you. I think that given the time, we should probably, Lorraine says there are no standards currently. This depends on recoverable frequencies.
Right.
Given the time, I think we should probably move on to our next speaker. Thank you so much, Tim. If anyone has any questions that come up during our next presentation, please feel free to use the chat or the Q&A, and we will be able to get to them at the end. So without further ado, I would like to present our next speaker, Christos Evangelidis from ORFEUS, who is a researcher at the National Observatory of Athens, where he manages the National Broadband Seismic Network and the European Integrated Data Archive National Node at NOAA. He currently serves as the elected chair of the IDA Management Board of ORFEUS. Thank you so much for joining us today and giving this presentation. We really appreciate it. And without further ado, the floor is yours.
Thank you. Thank you so much. Thank you for giving me the opportunity to present more or less what is ORFEUS, what is the ADA infrastructure, the federated system. I enjoyed very much the presentation from Tim, and fully support this initiative from the FOLDS initiative that should make new services, new web services available for all of us, the federated data centers. And we will extremely happy to host extra web services and APIs to expose this old data, the old or unavailable data from subduction zones or from elsewhere in the world. So I will present you in this coming minutes what is actually now available, at least from in the European domain. And I will give you an overview of the federated system, the subset of the federation for available data from the European perspective. Okay. So ORFEUS, which is actually our head, is the European infrastructure for seismic waveform data and station metadata, and it's a non-profit organization. We all belong to it. And it coordinates the infrastructure for all these distributed data archives in the European community through the European Integrated Data Archive, ADA, that I will show you later on. So it provides access to the high-quality seismic waveforms and station metadata from broadband and strong motion stations and also products. So all this is a working effort of a collaborative group of many people across Europe, and various groups and various, let's say, boards of directors, of participants, and so on, committees, specific boards, groups, and so on. So I thank all of these, and we should acknowledge all of this. We are on top of us, there is EPOS, which is something like, let's say, our head in Europe for all providing data concerning plate observation. And then all of our developments, everything is mainly funded from European projects. Okay, so we don't have constant funding for this infrastructure. We have national funding for the data centers, and then all the developments are based on projects. So we have three main domains across ORFEUS. So one is the ADA, as I told you, the European Integrated Data Archive, that provides data and metadata, raw waveforms, and the metadata of these raw waveforms. This domain could, of course, host legacy or unarchived data, and I'll give you some details later on. Then we have, of course, the strong motion event-based data services that they are mostly processed waveforms and gives details about big ground motions and also some enhanced information about the event and the site. In this project, in this domain, we already host some legacy data, and we have scanned and digitized analog earthquake recordings of engineering interest mostly. And then we also have in the domain of the mobile instrument pools and services that in another way we enhance the community access to onshore and offshore portable instrumentation, as the US you do in US with other initiatives. So for ADA, we currently have 11 primary nodes: BGR in Germany, ETH in Switzerland, GFZ in Germany, COER in Turkey, UBA NORSAR in Norway, ODC in the Netherlands, INGV in Italy, RECIF in France, NOA in Greece, NIEP in Romania. The new kid on the block is BGS from UK. And we have two secondary nodes, the LMU from Munich and ICGC from Barcelona. And soon we're going to have one more node coming from Spain in Madrid. And we have also some very good contacts, and we're proceeding on having new partners from Portugal, IPMA, AFAD in Turkey, and IMO in Iceland. So all these nodes, they're providing at least 23,000 stations, data from these stations, either closed or open ones. More or less 5,000 stations already in operation. Some of the stations are very old, and they can, for the legacy data point of view, these stations that they're providing now real-time data, they have old analog recordings from the past, right? Some of those, and they can be scanned and hosted on the same repository, I would say. So we have broadband, strong motion, short periods, OBSs, infrasound, gravity, and now we're trying to include DAS data. So we focus on the European and Mediterranean region, but we still have global experiments or data from overseas territories. We have data from volcanoes from the French overseas territories, and so on, or data from earthquakes, from tsunami-prone regions in the Indian Ocean, and so on. More than 135 permanent networks, temporary networks. All these networks, all these permanent networks and temporary networks, they provide officially to us, to all the nodes, supplier letters. So we have some supplier letters, and we as nodes, the 11 nodes, we have an MOU with ORFEUS. So we have quite a lot of users, unique users, and plenty of we ship a lot of terabytes per month to all the researchers. All these services, as I saw before, the nice web services that the team proposed for faults availability, station, image select, and so on. But already all the federated data centers across Europe or in the world, IRIS and so on, we offer the basic data services that someone can get information for stations and data from each station. So it's the data select. So for us in ADA, The ADA data center has its separate web service, an FDSN data select web service that gives the data in miniseed format, a station web service that gives station metadata in XML or text format for the stations, availability information for each station and channel, the routing ADA service that gives the details about where each station or network resides within our federation, and WF catalog web service that gives quality metrics for the data. And on top of this, we have the federator. So if someone doesn't know exactly where a station resides, in which node, we can go directly to the federator. And the federator is the web service that you don't need to know where something resides. It might be a little bit slower, but you will get the results without knowing in which data center this data resides. And of course, on top of this, there are the smart clients from OpSpy, FDSN scripts, and so on that the community, the seismological community makes, and they can approach these web services and get the data. So that's another image how we manage, let's say, our federation. In Europe, we have in the middle of the cycle, we have the data suppliers, the network operators. These network operators provide the data to one node. These nodes, they talk to each other. Each node has its distributed web service that provides information about the station, data, and quality of the waveforms. And through the routing, all these nodes that talk to each other, so we can have an ADA centralized service that talks to all the system, and someone doesn't need to know where something resides, just request the data and gets them. And on top of this, I have told you before, there are the smart clients on top left that someone can use them on the OpSpy smart clients or other smart clients and use this web service and get directly the data. So in order to go to the discussion we have for unarchived or legacy data for subduction zone, to be more specific, we see it right now without having these very nice web services that Tim showed us before. We have, let's say, right now 3 cases that we identify that we can see and identify available data in Europe that we can host more or less in an ADA infrastructure. So firstly are all these seismic records from paper and film, dating from the beginning of, from late 1800s to late 1900, collected across various European institutes. These records, at least in Europe, are largely undigitized and have yet to be converted in miniseed format, with, of course, making some station XML files. We also have, as a second case, we have the old analog data, the more modern one, I would say. The primarily more of this data are event-triggered weak or strong motion records from roughly the 1970s to 2010. Some of this data have been extensively converted by several ADA nodes. For example, ETH and Zurich converted many of these data in miniseed formats, and they provided the appropriate XML metadata. And this data are already in ADA, I will show you later on. And then for subduction zone, the subduction zone monitoring, the unarchived data, in our case, are the other equal space time series, both historical time series and recent ones, that are missing from ADA or in general from, let's say, FDSN data centers. Some of those are the infrastructure data, dust data, high rate GNSS data, and also tide gauge data. They are not all of them are within our FDSN web services. So I will give you some examples from the European domain. These examples are not necessarily related to subduction zone, let's say, data or monitoring, but nevertheless, I have to show you what is there in our case in the federation. So I will start with Germany. There is a very strong initiative, large initiative in Germany currently ongoing, It's a project, I don't know the name of the project exactly, but there are all the major big institutes that had old analog records in Germany and stations in Germany from the very old times. They're trying to estimate the effort to sustain and preserve all this historic analog seismic data in Germany. The working package one is already done, which is the data inventory, to make a data inventory with analog, an analog seismic catalog, I would say. There are 12 seismic data archives at different institutes and about 1.6 million analog seismic records and the metadata of these seismic records. Now, the working package 2, which is in progress, they test the procedures for the development of how to preserve this historical earthquake data. So they selectively scan seismograms from 3 seismic stations from 3 months period for this different data centers, I would say, and they're trying different vectorization tools to see what's the more suitable or which ones are the most suitable. And they're doing that with using just for 2 local earthquakes and 1 nuclear test in the area. That's recorded for all the, let's say, the seismic stations. And the next step that is going to be later on, they will build a working plan for the preservation, digitization of the analog seismograms. Göttingen, Frankfurt, Karlsruhe, Leipzig, Grafenberg, etc. They're already there, and other big institutes. And please talk to Galina Kulikova or to Klaus Tamler from BGR in Germany if you want more details. So in UK, the British Geological Survey has a lot of legacy data that are not available in BGS at ADA yet. They have around 3 million seismograms from WWSSN stations worldwide, as they say, from January 1966 to September 1990. And the seismograms are all on microfilm. And they have over 100,000 UK historical seismograms from UK that operated between 1896 and 1960s. All these seismograms are on paper and microfilm. And they're trying to digitize this recording for earthquakes around the British Isles, I would say, mostly. And they will try to include them in the BGS at ADA, the new established ADA node. So, and they also have the paper bulletins from the UK Seismological Observatories, as most of us have. If you need more details about that, please contact Brian Baptiste from BGS. And other efforts, digitization efforts or preservation efforts for historical or unarchived data in European ADA data centers, apart from GFZ, as Tim showed us before, and the effort they did with and they're working together with Tim in Folds or with the Catalonia ICGC that they're working together with Tim. At NIEP in Romania, an archive of around 4 million paper seismograms of helicorder has been preserved. They're covering the period between 1977 to 2002. They have scanned over 150,000 of these helicorders in high-resolution images, and they focus on events with sufficient magnitude. I would say that the subduction zone here is the Branchia subduction zone, okay? So, of course, they have crustal events of surface events, but they also have some subduction events, the deep subduction event of Branchia. Contact Alessandro Marmonareu from NIEP. At Koeri in Turkey, in Istanbul, paper earthquake records primarily covered in Turkey and surrounding regions have been maintained. Only limited number have been scanned and digitized. The area here, of course, is in the North Anatolian Fault, the Hellenic subduction zone, the Aegean and Central Turkey, of course. Please contact Didem Kambaz from Koeri. And at Noah, where I reside, we have many smoked paper seismograms records for events in Greece dating to the early 900. They have been stored. Most of them remained unscanned. We have Vichert, mainly Vichert and Mainka records. We have a decade of continuous helicorded data from all the Greek seismic stations covering the decades of 80s, 90s. but unfortunately we lost a lot of records due to a fire from the whole Greek network. We cover the Hellenic mostly the Hellenic subduction zone. If you need more details, please contact me. That's some seismic records from paper from Koeri. That's an earthquake in 1935 in Turkey, in the Marmara Sea, as it was recorded in ISK seismic station. You can clearly see the seismogram with baseline slip and the paper that describes how they digitize this event is the following, as I give you here in the presentation. And it's another picture of the same event, how they corrected the event, how they did the curvature correction, and so on. The same event. So that's a 1935 in Marmara Sea, a 6.4 event. For the Greece case, what we're working right now with collaborators from University of Thessaloniki is the following. We have the Hellenic subduction zone, as you can see it, the highly curvature subduction zone, where we have, of course, we have crustal earthquakes on the Aegean crust, but we also have earthquakes from the subduction interface. These earthquakes were happening along the subduction interface, let's say within the green zone or the yellow zone. These earthquakes, and imagine that on the past we only had 1 or 2 stations in the main cities. So let's say we had a station in Athens, which is located in the Barkark area. Okay, so if we had an earthquake happening just below on the subduction interface, then the wave that was traveling through the mantle wedge, so it was highly attenuated. So if we had an earthquake, as you see in the example on the right-hand side, if we have an earthquake on the, let's say, where is the red star, 130 kilometers depth near, let's say, Santorini volcano, where you see, you can see that a station on the Barkark will have much smaller amplitudes and amplification due to the strong attenuation of the mantle wedge, whereas a station on the Forekark will have much higher amplitudes. So in this case here, where I show you, we had an earthquake in 1964. It was an earthquake 6 below Athens, and it was 155 kilometers below Athens. But the initial feeling was that the stronger shaking was happening somewhere in the southwestern Greece. So this earthquake was initially associated as a surface earthquake in southwestern Greece. And then they saw back then the seismologists, they saw the Vichert recording of this earthquake, where you can clearly see the P wave. So what we do right now is we scan and we try to digitize these recordings to explore more these deep earthquakes, deep fork earthquakes that are happening below across the subduction interface, but they are recorded only on stations that they are on top of the mantle wedge. So that's why we need the old records and the old waveforms scanned. And then if I go to ETH, as I told you before, in ETH they did that already. They scanned all the old analog records as event-based on an event-based manner, and then they converted to Minisit, and they fixed the station metadata for this, and then they added the stations to the existing database across ADA. So if you go to the service availability at ODC and you check a specific station for a specific channel, then you can see this scattered, let's say, availability, these red dots that represents, let's say, data with huge gaps in a continuous manner, which is not. Of course, they're not continuous. The data, they are event-based data within a continuous-based, let's say, interface as we have it today. And so you can discover them and download this data directly. So, and then I will go finally I close with this to what's happening from now on, how we can, our effort to host across ADA and generally FDSN, all these discussions to host equal space time series relevant to subduction zone. So, of course, there are initiatives to host across the FDSN data centers infrasound data. For us in Europe, NIEP and NGV, they're doing that already. We also hosting strain meter data, and Recif in France is doing that already. Then the new kid of the block is, of course, the way to host DAS data from cables, underwater cables, or general cables. Our idea here is the following, and I'm giving you this picture here. That's a cable that's passing from Greece to Italy, but you can imagine a same cable going on top of a subduction zone and passing, let's say, from southern Greece to Egypt, okay? So the idea is the following. We have a DAS on one side, and this DAS, the new DAS equipment is also capable of having a seedling protocol. So in other words, you can transmit in real time some sample data of this acquisition, okay? So if we have, let's say, a DAS on one side and we sample 1,000 points, we will select from this 1,000 points, let's say 10 points every 10 kilometers or 20 kilometers. We will select the best point, and we can transmit this point as virtual OBSs in near real time to the data center. And from the data center, we will provide them to ADA data centers directly and give them available to the public. That's our current project we're trying to implement here between Greece and Italy. And then if we do that, then we can employ and do the same for across subduction zones, specifically in areas where we have sea, okay? So, and then another effort is that GFZ is working to host high-rate GNSS data in real time and tight GOATS data again for as I told you before. So ADA, the way we are now, and before we develop all this in association with FDSN and all this fold initiative, the way we have it right now is that we can disseminate unarchived and legacy data as long as they have a station XML descriptive file for the station metadata, and they are transported in minisheet, the wavefrom data. Of course, this wavefrom data and station metadata should exist in this format. They should be provided in a FAIR principle, as Tim said before, and they should be accompanied by a license, CC by 4 or an equivalent license. And of course, an ADA node should agree to host the data and the metadata, which is, I think, the easiest case. So we ADA nodes in principle cannot help in the digitization process of old legacy data, but some of us, we are not only ADA nodes, we are also network operators. So in other words, we are willing to strongly involved in all this process of the digitization, the preservation, and even the development and let's say testing of these new initiatives for old and unavailable data. So thank you very much, and I'm open to any questions.
Thank you. We already have a question from Tim. Does IDA have plans to support storage of image files resulting from scanning or just data after vectorized/digitized?
From the time being, we can only host the vectorized data, okay? But as I said, we are Tim. You're already working with one of our main, let's say, developers and strongly involved people, Javier Quinteros. So we across ADA, we are more than willing across with you and Iris to work together and add more web services to the public. So in other words, my personal opinion is that the data from from the old legacy data, it's only a very small fraction of the space we need from the new data that are coming right now from the dense large N and DAS experiment. So it will be a waste of resources and space if we won't do that. So I would say I would strongly support this to host also the images. Of course, by discussing that with my other colleagues across ADA, right?
Thank you. The chat and the Q&A function are both open for questions if you would like. Tim says, my quick calculation for the amount of image file storage needed for your 1.6 million analog records is nearing a petabyte. Do you have OKs to store that much?
1.6 million analog records is from Germany, right? That's what you're saying. Well, that has to do with each ADA node. We are a federation, so it's a federated data center can make its own management and how much data can host. So my first answer to that is that some of these nodes are already willing to host very large data sets from DAS, as I said before, in large N, either in S3 buckets or in their own hosted data centers and NAS systems. So for my case, well, I do know that I don't have 1.6 million analog records at NOA, and I have much less. I'm willing to host all of this to the data center. So it's a discussion.
Thanks. I don't see any more questions for the time being. I'm going to use this quickly to just say that the video of the recording of this session, the last two keynote talks, will be uploaded to the SZ4D YouTube channel later today, and all of the activities from yesterday were also uploaded to the SZ4D YouTube channel. I'm going to put that link in the chat just in case people missed it and would like to watch those asynchronously. Oops, sorry. I will send that to everyone. If you think of a question that you want to ask one of our panelists after this webinar is done, feel free to email us and we will pass that along. In the meantime, we do have a question from Lorraine. Do the imaging projects have preference for the format standards, JPEG versus TIFF? Christos?
No idea. I'm not I'm not working on the imaging project, so I have no idea. I would say yeah, no idea.
Okay, if we don't have any more questions, we're nearing the top of the hour. Our series of short talks from Chileans. We might have a question from Wilfried. Do you want to put it in the chat? Okay, sorry. Our next activity is a series of short talks from Chilean scientists discussing the state of data in Chile. That will be in about 30 minutes, and I'll be using the same link as this current webinar. We hope to see you there then. And if you have any questions for any of these panelists in the meantime, please feel free to send us an email, and you will be able to rewatch these recordings at the end of today. Thank you very much, and we hope to see you in about 30 minutes.